It's in YouTube also, Nana. If you want to join there in YouTube, you can join there. Yeah. Okay. Okay, Nana, we will start the class today. Okay. Yes, I think in the previous class we discussed about a few applications of parallelogram law of vectors, if I'm not wrong. Okay. So today we go with here. I think you already remembered the parallelogram law of vectors. Okay. When two vectors are given to you, generally we take them as the adjacent sides. Am I right? And we take like this, I think, as the adjacent sides. And originated from the same point, right? So originated from the same point means better you take it as some O, and this is the first vector A bar, and this is the second vector B bar, magnitudes A and B. And then you constructed the parallelogram as usual, like this. And the diagonal taken from the same point gives the resultant vector. From the past 3 days, we are discussing the same point. Okay, nothing to explain here. And the angle between the two vectors is theta. What we think? And it is the magnitude of resultant x, and that x also for the past 2 days we did few models also. So I think all of you remember the formula a square plus b square plus 2ab cos theta under root.
Yes, sir.
Correct only. And then here this magnitude yesterday means in the previous class we concluded that it gives the magnitude of what the addition of two vectors. Okay, good. Now today we focus more on what here. This is addition of two vectors, okay, of magnitude root of a square plus b square plus 2ab cos theta. Here I gave, okay, means if anyone asks you what is the magnitude of addition of two vectors, you can say it's very simple. It is x, and that x is equals to a square plus b square plus 2ab cos theta under root. You can say very easily the answer. Okay. Then suppose the same person ask you that resultant, which is addition of two vectors. Okay. Magnitude you are saying very simply. What about the direction? If someone asks you, direction means, suppose if you assume it as x-axis, okay, with x-axis, like what he is asking, with x-axis, the resultant vector means this one, okay, resultant vector makes how much angle with x-axis? If they ask, I strongly believe that it is not theta. Am I right, Nana? It is not theta. Okay. Yes, respond please. Is it theta, Nana?
Yes, sir.
Yes, sir.
Look at the diagram. Is it theta?
No, sir.
No, actually total angle is theta. Okay, I am asking this angle. Don't say, sir, intersect is bisecting the angle. It may be theta by 2. Okay. Don't say like that. I don't know. So I am going to find out what is this angle. Okay. So I'm going to find out here today what if I give the names like OA, suppose this is C and this is D. Okay. And if you give the name here like some P, okay, I am asking what is the angle COP. Angle COP equals to how much? Whereas you know that angle DOP is equals to theta. You know it. Okay. If I ask this angle, let it be. Even I also don't know. So I am assuming it like some angle alpha. Okay. Angle COP, I am taking it as alpha. Alpha equals to how much? This is the question. Okay. Directly, I can't write like tan alpha or cos alpha or sin alpha or cot alpha or something. Why? Because OCP is not a right angle triangle. Okay. So to form right angle triangle, what to do? If I ask you, I think you can say the answer very easily. Sir, simple. You just drop a perpendicular like this. Okay. This is a perpendicular. Okay. And it is having the magnitude B. Still anybody here remembered, Nana? Suppose if I give the name here like a Q, B is resolved into two components. Will anybody give the values of PQ and CQ? Anyone remembered?
So PQ is B cos theta. CQ is B sin theta.
Very good, Nana. Very good. Lakshmi Gayatri. Very good, Nana. I think you remembered. CQ is B sin theta. B cos theta. Okay, right.
Yes, sir.
We are taking it as B cos theta. Okay. Now it is a right angle triangle. In that, if I keenly observe, actually I am seeing two right angled triangles here. One is OCQ, other one is PCQ. Okay. So first of all, I am going with OCQ right angle triangle. So from the right angle triangle OCQ, what I want alpha. I think in just one step we will get the answer. Tan alpha is equals to from the triangle. Who is the opposite side from tan for alpha, Nana? In this triangle?
B sin theta.
B sin theta. Means can I write like first CQ?
Yes, sir. CQ.
Yes, sir.
CQ divided by, will you say in the same way?
PQ.
Is it P?
Okay, yes.
Okay.
Right. So it is OQ. Very good. CQ by OQ. That implies tan alpha is equals to, can I write here? CQ divided by OQ whole thing. Can I split like OP plus PQ, Nana?
Yes, sir.
Right, good. Direct, just to substitute the values, you will get the answer. Tan alpha is equals to, straight away you will get the answer. Tan alpha is equals to CQ. CQ value here already is there on the board. It is B sin theta by divided by OP. Value of OP, you know, it is having the magnitude of A. So A plus here PQ magnitude is B cos theta. So tan alpha is equals to B sin theta by A plus B cos theta. Anything wrong in my derivation, Nana?
No, sir.
Right, correct only. B sin theta by A plus B cos theta. Correct only, Nana. Okay. So this is tan alpha. Okay. So here in the parallelogram law of vectors, if you squeeze out what are the important points, okay, number one, The magnitude of resultant vector is root of a square plus b square plus 2ab cos theta. And its direction is tan alpha is equals to b sin theta by a plus b cos theta. Okay. So tan alpha finally gives what? If anyone asks you, what do you say? Don't say it gives angle.
Direction.
Yes. Tan alpha gives the direction and x gives the magnitude. Okay. It gives the magnitude and tan alpha gives the direction. Very good. Good. That's right. Okay. So here today, if you focus more on how to find the direction, okay, using the formula b sin theta by a plus b cos theta. Okay. So I am going to say today the applications of finding the direction of resultant vector. Okay, resultant means addition of vectors. Okay, one by one we'll check, Nana. While finding out the magnitude, I think first application we took what? Example 1 that day, means in the previous class only, before Krishnastami. When two vectors are collinear or parallel to each other. Okay, I think all of you remembered that day we got x is equals to a plus b, if I am not wrong. Is it correct, Nana? That day we got mod a bar plus mod b bar.
Yes, sir.
Right. Parallel to each other. Today, for that example, I am asking, okay, two vectors are parallel to each other. Yes, madam. Then x is equals to mod a bar plus mod b bar. Okay. Now, its direction will be, if I ask here, what do you say? First of all, when two vectors are parallel means what is the angle between the two vectors, Nana? Parallel or collinear. What is the angle between the two vectors? Theta is
60 degrees.
collinear, Nana, parallel. Yes.
0.
Yeah, now it is correct. 0. Okay. So theta parallel or collinear, the angle between the two vectors is 0. Yes, correct. So theta is equals to 0 degrees means today we are going to focus more on this formula. No? So look at that formula, Nana. Here, tan alpha equals to, we write what? Check it once. B sine theta. Theta is 0 degrees by A plus B cos theta. Okay, cos theta 0. Okay, so this is equals to B. I think sine 0 is 1 now. Sine 0 is 1. Am I right? Anyone please respond. Sine 0 is 1 or 0?
1, sir.
Sine 0.
0.
0, sir.
0, sir.
Right. Don't get confused if I confuse you all. Okay, in the middle sometimes I try to confuse you. Don't get confused, Nana. So B into 0 by A plus B into cos 0 is 0 na?
1, sir.
This time you are correct. Into 0 is equals to B na? B into 0 how much, Nana?
0.
Very good. 0 by A plus B. 0 by anything equals to how much?
Zero, sir.
Right. Tan alpha is equals to 0.
Zero.
That implies alpha. Will you tell Nana alpha equals to?
0 degrees, sir. Alpha is 0.
Right. Why? Because tan 0 equals to 0. That implies alpha equals to 0.
0 degrees.
Right. 0 degrees means, look at, angle between the two vectors is 0 degrees. The resultant vector also makes an angle 0 degrees. Means, can I say these are the two vectors, A bar having the magnitude A, B bar having the magnitude B. The resultant vector X also will be in the same direction. Is it correct?
Sir.
Correct or wrong?
Correct, sir.
Yes, sir.
Very good. Yes, yes. So this is the way of finding out the direction of resultant vector. So first of all, the first example, is it clear, Nana, how to find the direction?
Yes, sir.
Yes,
Sure? Sure?
Yes,
Yes, sir.
yes, sir.
Yes,
Good,
sir.
good, good. Now go to the second example. What we discussed that day? That day, second example, I think I told when two vectors are anti-parallel to each other. It means opposite direction. Okay. Anti-parallel. Anti-parallel means opposite direction. Okay. Opposite direction. Then X is equals to, I think that day you remembered, this is equals to mod A bar minus mod B bar we got. Anyone remember this one, Nana?
Yes, sir.
Yes, sir.
Good. Today I am asking its direction will be again. Its direction, okay, will be, this is the question. Okay. Now we have to write the solution here. What will be the answer for it?
0 only, sir.
0. Okay, good. How can you say that is 0, Nana? Tan alpha is equals to what you are going to substitute in place of theta?
180 degrees.
Very good. Opposite direction means theta is 180 degrees.
180.
Okay. Right. So B sine in place of theta, I am straight away substituting 180 degrees here, divided by A plus B cos, again theta is 180 degrees. Sine 180 is minus 1, Nana?
0, sir.
0, sir.
Is it 0 or minus 1?
0, sir.
0.
Very
Zero.
good. Very good. Go by A plus B cos 180.
1, sir.
1,
Minus 1, sir. Minus 1.
Right. Good.
Minus 1.
180 is minus 1. Good. So here, you can say that this is B into 0 is not OB. B into 0 is
0.
0 by
0.
A. All together you
Minus
get
0.
0.
0.
Then alpha
Alpha
equals to
is equal to 0, sir.
very good. That implies alpha equals to 0 degrees. Okay.
0.
Now come back to the diagram, Nana. You took the alpha with the A or B. Here, alpha. Angle we assumed in the diagram, alpha, is it with A or B?
A, sir.
A, sir.
So can I say here, this is alpha is equal to 0 degrees with A or B?
With A.
A.
Very good. With A bar, alpha equals to 0 degrees. Okay. Now I am expecting one answer from you. Suppose if I take the two vectors diametrically, a diagram in that diagram here, suppose this is A and it is B. Now I have to take the resultant vector X in the direction of A or in the direction of B?
In the direction of A.
The direction of A.
Why, Nana?
Because alpha is with A, no, sir.
Very good. Alpha is equal to 0 degrees with A. So the resultant vector X will come in the direction of A. Is it correct, my diagram?
Yes, sir.
Right, good. So I think all of you understood the two examples here.
Yes, sir.
Yes, sir.
Are the two examples for everyone clear, Nana?
Yes, sir.
Yes, sir. Clear, sir.
Yes, sir.
Can I move to next? Okay.
Yes, sir.
Can I move to next page?
Sir, 1 minute.
1 minute, sir.
Yes, sir.
Okay. I'm moving. Can I move, Nana?
Yes, sir.
Yes,
Sir. Right, good. Yes. Here again, this is one important application. Okay. Of course, before discussing about the important application, better we go with the perpendicular, Nana. When two vectors are perpendicular each other. Okay, perpendicular to each other, right? Then he is asking in this example, the angle made by the resultant vector here with a bar. I am asking. Okay. Here I think if I write the solution here, when two vectors are perpendicular means, can I take theta equals to 90 degrees?
Yes, sir.
Yes, sir.
So here, after substituting that theta equals to 90 degrees, that day we got, means in the previous class, the resultant vector has the magnitude x is equals to root of a square plus b square.
Sir, answer is infinity.
I don't think. Once you check. Why? Because tan alpha. Okay, better I write the same equation here instead of going to the previous page. Equation what we got, b sine theta by plus. Right. In this case, if you substitute theta 90 degrees here, Nana.
Sir, it will be B by 0, sir.
B by A, sir.
I think the second person is correct, I think.
B by A, sir.
B by A, yes.
Right. B sine 90 by A plus B cos 90. Nana, what you are saying, this part is 0, Nana, I accept. Why? Because it is cos 90. Cos 90 is 0. 0 into B is 0. But 0 plus A is there in the denominator. Yes, good.
Yes, sir.
So divided by A. And here this is B. Sin 90 is all of 1. Right. So tan alpha is equals to B. Okay. Or alpha is equals to tan inverse B by A. Is it correct, Nana?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Now here, if I ask to draw the diagram related to it, can I draw like this? This is B bar. And perpendicular to it, this is A bar. Angle between them is 90 degrees exactly. And here the resultant vector taken from the same point here, like this. It is the resultant x. X makes an angle with A. Alpha is equals to tan inverse B by A. Is it correct, Nana?
Yes, sir.
So here you see it is perfectly matching with your Pythagoras right angled triangle concept, Nana. So A and B are perpendicular means once you check there, this is B, it is A. If you complete it as a rectangle like this, okay, the diagonal taken from the same point, it is the resultant vector x. I am asking alpha here. When two vectors are perpendicular to each other, look at there. No need to go to this formula, Nana. No need
sir.
this formula. Straight away you can say in this right angle triangle. Why? Because vectors are perpendicular to each other. Means here also the angle is 90 degrees. In this right angle triangle, straight away you can tan alpha is equals to opposite side by adjacent side. Opposite side, it is parallel to B bar. So its magnitude is B. So opposite side is B. Adjacent side, magnitude is A. Straight away in single step, we got the answer. Okay. But I think it is valid only in case of what?
Yes, sir.
Right
angle triangle, sir.
Yeah, right angle triangle. That too when the angle between the two vectors 90 degrees. Okay, perpendicular to each other. What Nana sir? Explain once again. Which one? This right angle triangle. From means which one, Nana? From here. Simple, Nana. It is two vectors are perpendicular. Means when the given two vectors make an angle 90 degrees perpendicular to each other, what is the angle made by the resultant vector taken from the same point? That one, using the formula here, we substituted in the formula theta equals to 90 degrees. We found alpha, Nana. This procedure is correct. But I am giving one shortcut here if the angle between two vectors is 90 degrees. The shortcut, what is the shortcut? If they are perpendicular, you can construct one rectangle here. In that, till here, if you see, means like if you give the names P, Q, R, S, PQR is one right angle triangle. In the right angle triangle, straight away without using the formula, you can say tan alpha is equals to opposite side by adjacent, that is B by A. This is the shortcut what I said. But conditions applied. It is valid only when two vectors are perpendicular to each other. Otherwise, we have to use the above formula. So now is it clear, Nana? Right, good. Now it is the time to take that important one. Previously, I gave the 5-star rating question. Okay. If the magnitudes of, this is very important for us again. If the magnitudes of given two vectors are equal, okay, are equal, means he is saying that mod A equals to mod B. Magnitudes are equal, A equals to B.
Alpha 45 degrees, sir.
That's what I'm asking. See here, if you go in hurry, I think you will tell the wrong answers. Okay. Once you look at the question, what I'm saying, a magnitude of given two vectors are equal. Okay. And the angle between the two vectors, I'm saying theta. Then instead of writing everything, directly I'm asking alpha equals to how much? Now you understood the question, Anna, first?
Yes, sir.
Okay. I think you won't get 45 degrees here. Can I write again the formula? Tan alpha is equals to what is our formula? B sine theta by A plus B cos theta. Good. But A is equals to B. So in place of A, I am going to write B there. So B sine theta divided by, I'm going to get there. Okay. In place of A also B, B plus B cos theta. So
Yes,
next,
sir.
what can you do, Nana? Numerator, nothing, no change is there. B sine theta only, numerator. Divided by, anything can you do here in the denominator?
2B, sir. B common,
Is
sir.
it, is it 2b or b common?
B common, sir. 1 plus cos theta.
Yeah, very good. B common.
B
B into 1
1
plus cos theta. Try to go to the mathematics. Of course, B get cancelled here. And denominator 1 plus cos theta, try to recollect.
Cosecant theta plus tan theta.
No. Like that day I asked a few questions.
No.
Cos theta is equals to, you can write it as 1 minus 2 sine square theta by 2.
Yes, sir.
Or 2 cos square theta by 2 minus 1. Okay. From here, I think one of you told the answer also. 1 plus cos theta from this equation. You can write from mathematics. 1 minus 1 taken to the other hand. 1 plus cos theta equals to, you only told, 2 cos square theta by 2. Am I right? That day I asked
Yes,
you
sir.
all. Who
Yes, sir.
told this formula, Nana? You said that day, sir, Sharat sir told this formula, sir, 1 plus cos theta is 2 cos square theta by 2.
Yes,
Yes?
sir.
Right. So 1 plus cos theta is, according to Sharat sir's formula, it is 2 cos square theta by 2. And sin theta also that day I asked. You told sin 2 theta is 2 sin theta cos theta. And sin theta you told that day 2.
Sin theta by 2 into cos theta.
Yes. That I am going to write here. These two from mathematics I am substituting. Sin theta is 2 sin theta by 2 cos theta by 2. So anything get cancelled here, Nana?
2 cos theta by 2.
2 and 1 cos theta by 2 get cancelled.
Yes, sir.
So here you are getting, this is finally what? Sin theta by 2 divided
Tan
by,
theta by 2.
this is sin by cos, tan. So tan alpha is equals to tan theta by 2 means both sides tan function we got.
Yes, sir.
So tan function cancel. If you will get what, Nana? Alpha is equals to
Theta by 2.
exactly theta by 2. Okay. So from this very important example in the direction, okay, what the concept you learned?
If both the magnitudes of the vectors are equal, then alpha equal to theta by 2.
Theta by 2 means, why don't you say that is
Angle.
exactly half of the angle means
Half.
bisect or not?
Bisect, sir.
So that
90 degrees.
Yeah, not 90 degrees.
45
Means suppose
degrees.
not 45 degrees.
Yes, sir. Understood.
Suppose two vectors are making an angle, say some theta, the resultant exactly bisect the angle like this.
Yes, sir.
One angle is theta by 2, other angle is theta by 2. Exactly bisect angle.
Okay, sir.
Okay, na? This one we have to write in words.
Okay, sir.
How to write in words? I am going to write here in words. If two vectors, sorry, here, if two vectors have the same magnitude, have the same, yes, where he came. If two vectors have the same magnitude, then the resultant bisects the angle between the vectors. Okay, is my concept statement correct or wrong, Nana? Once you read, if two vectors have the same magnitude, Yes. Then the resultant vector bisects the angle between the two vectors. Anything wrong in my statement, Nana?
Correct only, sir.
Provided bisects, provided
Nothing
vectors
wrong.
have, right. Two vectors have same magnitude or different magnitude.
Same magnitude.
Then only the resultant vector bisects the angle between the two.
Angle.
Okay. If you understood this concept, can I move to next page, Nana?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Right, good. I'm
One
going to the
minute,
next.
sir. 1 minute, sir.
Sure, Nana. So can I move?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Coming to next page here. If you understood my concept there, what I told, here try to say the answer. Suppose two vectors are at an angle 120 degrees, okay, and their magnitudes are equal. Then the resultant makes an angle, Nana, these many people are opening their mics and I'm getting a lot of disturbance, Nana. Okay. Now, here then the resultant makes an angle with one of the vectors is directly the answer.
60 degrees.
How can you say that is 60 degrees, Nana?
Sir, if both the
Magnitude
magnitudes
is
are equal, then we can apply the formula tan alpha equal to tan theta by 2.
Means
Alpha equal
equals,
to theta by 2.
now you are right. That implies alpha is equals to 120 degrees by 2. Theta is given as 120. That is equals to 60 degrees. Very good. You are right now. Okay. So here the angle is exactly 60 degrees. If the angle is here 40 or 90 degrees perpendicular, Nana?
45 degrees.
45 degrees.
Right. No need to solve. Straight away we can say the answer. Provided the two vectors have equal magnitudes, then only we use this. Okay, am I right?
Yes, sir.
Good. So here I think you understood the concept of finding out the direction.
Yes, sir.
So here in the previous class and today we completed what the part addition of two vectors. Okay, addition of two vectors, how to find the magnitude, how to find the direction. Okay, right. Once again, try to recollect the formula and a direction, how to find tan alpha is equals to, what is the formula?
B sin theta
B sin theta by A plus
cos theta.
A plus B
B cos theta.
Cos theta.
Right. And try to recollect the magnitude. This one I think very easy. Many times we applied.
A square plus
A
B
square plus
square
B square
plus
Plus
2AB cos
plus
theta.
2AB cos theta.
Right. This is the direction and it is the magnitude of addition of vectors. Okay.
So,
Here briefly we recollected the two formulae what we used here. Angle means direction and magnitude. Okay. That addition of vectors, here he is asking. Okay, what? Suppose if I write two vectors as the addition of two vectors, okay, is, suppose written as A bar plus B bar. Okay, addition of two vectors. Then the question is, A bar plus B bar, is it equal to B bar plus A bar or not? What do you say with your knowledge? Sir, buffering. It is not buffering, Nana, I think. Is it buffering, Nana?
No, sir, it's clear only, sir.
No, sir, clear.
Yeah, it's
Sir,
clear.
No, sir.
Yeah. Okay, right. So look
Only
at,
only for someone it is buffering, sir.
I think it is the technical issue there at their home, not at me.
Yeah, yes, sir.
Yeah.
Yes, sir. Is the network issue?
It is their network issue.
Yes, sir.
So look at here, Nana. The addition of two vectors, generally we write A bar plus B bar. Okay. That one, instead of A bar plus B bar, if I write like B bar plus A bar, anything wrong?
no, sir.
Sure?
No.
Sure?
Yes, sir.
Here, in case of mathematics, if I ask 3 plus 2, is it equals to 2 plus 3? Without second thought, you say, sir, both are equal.
Yes, sir.
3 plus 2 is 5, 2 plus 3 is 5. Okay.
Yes,
But here, A bar plus B bar, straight away you are saying that it is equals to B bar plus A bar. With what confidence you are saying like?
sir, I kept the numbers in place of A and B.
Yeah, just by keeping the numbers in place of A and B. But here problem is, Nana, okay, I accept A bar plus B bar. If they ask the magnitude, formula already there on the board. So straight away I say the magnitude of A bar plus B bar is equals to, according to the formula, I say root of A square plus B square plus 2AB cos theta. In the same way, if you ask the magnitude means mod, magnitude of B bar plus A bar, if you ask me, that one I write it as root of, first B I am getting, so B square plus A square plus 2BA cos theta. I think these two equations are equal according to mathematics. Anything wrong, Nana?
No, sir.
So what you are saying, magnitude of A bar plus B bar is equals to, here already shown from these two equations, we write magnitude of B bar plus A bar. Okay. But that is the vectors chapter. Now we have to show that A bar plus B bar direction and B bar plus A bar direction is also same. Am I right, Nana?
Yes, sir.
So that one here I am asking. Okay, look at here. Suppose this is A bar. Okay, and this is B bar. If I put the directions also, A bar direction, and this is B bar direction. Okay, I think for whole thing, it is the starting point and it is the final point. So if I ask A bar plus B bar, we have to start from here. Am I right? Correct, Anana?
Yes, sir.
So I have to start from there. From here to there, I just draw one line and putting the arrow marker starting from here and finally reaching to that point. This is A bar plus B bar having some magnitude with A bar. This is alpha. Okay. So it's a direction. Tan alpha is equals to what I write with the A bar, B sine theta by A bar, B cos theta. Okay. Now it is the time for you all. Yes, what's here? How to find the direction of B bar plus A bar? There's absolute silence. Sound.
Sir, by drawing a parallelogram opposite side, we can the diagonal. We can
Okay,
get the
you are
diagonals.
saying that first to draw the parallelogram.
Yes, sir.
Okay, Nana. According to your wish, first I am drawing the parallelogram. Okay, I think it is almost parallel. And here, taking the line parallel to it. Okay, right, good. Then here, who is this one, Nana? This is B bar or A bar?
B bar, sir.
B bar, very good. And who is this?
A bar.
A bar.
Okay, right. So now starting from here and finally coming to there. Okay. So B bar plus A bar. Okay. I am writing here. This is A bar. Okay. B bar plus A bar means I think I have to join like this now.
Yes, sir.
Correct only?
Yes, sir.
So if I join them, look at both are parallel or something.
Parallel, sir.
Parallel means over now both are in same direction.
Yes, sir.
Is it clear?
Yes, sir.
Upper line is what? B bar plus A bar or A bar plus B bar?
B bar plus A bar.
Very good, Nana. B bar plus A bar. Yes, here Shreya P raised hand. Yes, Nana, any doubt, Ratali? Shreya P, any doubt, Nana? No, okay, right, good. So I think she wants to say that it is correct only. Right. So B bar plus A bar. So A bar, bottom one is what, Nana?
A bar plus B bar.
So better I erase here. That is A bar plus B bar.
Yes, sir.
Oh. Yeah. Better I have to draw one more line.
I have a doubt. Excuse me, sir.
Sure, Nana. Who is this?
Here, I'm Gayatri, sir. The top
Nana.
line, it's B bar plus A bar, no, sir. How, sir?
Simple, Nana. Here, first what you have drawn there, look at, I'm redrawing the diagram. This is what? Is it B bar or A bar, Tali?
B bar, sir.
Very good, Nana. And here, who is this?
A bar, sir.
Very good. And here, out of the whole diagram, who is the starting point? Is the bottom one or the top one?
Bottom one, sir.
So we have to join from bottom to top. Am I right?
So it's
So
B bar plus A bar.
So you are starting from B bar plus A bar. Is it clear, Ratali?
Yes, sir.
This one, what I have drawn here. Okay, na? So top one is B bar plus A bar and bottom one is A bar plus B bar. Actually, what I asked, are they both in the same direction or not?
Both of them are in same direction.
Yeah. Whereas, they are parallel to each other. Parallel to each other means same direction, Nana?
Yes, sir.
Right, good. This is actually A bar plus B bar. Yeah, this is A bar plus B bar. And that is B bar plus A bar. Both are in the same direction means, can I say they are in the same direction? Can I say, Nana?
Yes, sir.
So B bar plus A bar, magnitude, already you proved that they are equal. Magnitudes are equal. Directions also same direction. Okay. Magnitudes same. Directions same. Therefore, here can say
addition of two vectors.
Addition of vectors are equal or unequal?
Equal, sir.
Therefore, now confidently I write A bar plus B bar is equals to, without second thought, B bar plus A bar. This type I think you named in lower standards as some law.
Commutative.
Commutative property.
Good. So addition of vectors obeys your commutative law. Okay. Therefore, addition of vector obeys the commutative law. Okay, na? Now try to recollect what is meant by associative law. Do you have any idea in your lower standards?
Yes, sir.
What is that, Nana?
Sir, if three numbers are given, you add them in any order, you get the same answer.
Very good. Associative law.
Yes, sir.
Means you are saying like 3 plus 4 plus 5 is equals to, you can write it as 3 plus 4 plus 5 in scalars.
Yes, sir.
Right?
Yes,
I
sir.
think already you proved that addition of vectors obeys commutative law, means here this one no need to prove. Straight away we can write. What, Nana? A bar plus, can I write here? Plus
B bar.
some other vector, C bar. Is equals to, how can I write?
A bar.
A bar
Plus B bar bracket
in bracket, very good.
plus C bar.
That's it. So it obeys the associative also. So do you want any proof for it, Nana?
No, sir.
It's very easy. Why? Because already we proved here in addition. I think the proof is not required. Okay. So straight away we write here associative law. Yes, addition of vectors obeys the law. The associative law. Already I wrote at the top, so obeys the law. That is, I write here, A bar plus B bar plus C bar is equals to A bar plus B bar plus C bar. Okay. And here, this is actually your subjective question, subjective question, Nana. Okay. In physics, actually, you have 3 types of questions in subjective exam: 8 marks questions, 4 marks questions, and 2 marks questions, Nana. Okay. In that, they may ask these 3 laws here as 4 marks question. Subjective question. Means what they say, state and explain the 3 laws of addition of vectors. Okay. First law already over. What is that, Nana?
Commutative.
And second law is
Associative law.
over. 2 laws are over. Next, we are coming to the last one. What is that? It is called as distributive law. Okay, third one. Distributive law.
Closure law.
Do you know that, Nana? This distributive law?
Sir, distributive properties, sir.
Simple distributive property. Very good. Like 2 into 3 plus 4 is equals to, we can write. Sorry, 2 into 3 plus 4 can be written as 2 into 3 plus 2
4.
into 4. Distribution. Okay. In the same way, you have to write in vectors. But one is a scalar, the remaining 2 are vectors, Anna. Okay. I'm going to write here. I think you can understand. This one I am writing like, suppose one constant, say some k, like 2 or 3 or 4, k into A bar plus B bar. Addition I wrote here. Now it is the time to distribute. Distribute this one, Nana. Into A bar.
Plus K B bar.
That's it. We distributed the addition of vectors now. These are the 3 laws. Okay. Commutative law, associative law, and distributive law. All the 3 are here, Nana?
Yes, sir.
Sure?
Yes, sir.
Okay. Right. Do you have any doubts here?
No,
No, sir.
No.
No doubt, sir.
Very good. So addition of vectors part is over, Nana. Okay. We completed addition of vectors today. Okay. Next, we have to come to, sir, no doubt. Yeah, good. No, sir, no doubt. Right. Next, we have to come to the subtraction of vectors. This is very dangerous part in vectors. Okay, addition over, we have to come to subtract. How to subtract the vectors? Okay, subtraction. That of course, it's already around 4. Today I am not explaining that concept. I will explain it tomorrow. Okay, subtraction means, like in mathematics, if I ask, array, is 3 minus 2 is equals to 2 minus 3, without second thought, you say the answer. Are they equal, Nana?
No, sir.
No, sir.
3 minus 2 is plus 1. 2 minus 3 is
One.
minus 1.
Minus 1.
So
Minus
these two are not equal means straight away you can say, sir, subtraction of vectors does not obey the commutative law. Why? Because they are not equal. So it does not obey the commutative law. It does not obey. If commutative law is not obeyed, there is no question of associative law. So what do you say? Associative law is valid or not valid?
Not valid, sir. Only
Ah,
distributive law is valid.
Very good, very good. But we can say some 2 into 4 minus 3, we can say it as 2 into 4 minus 2 into 3. Okay, distribution is possible. So it obeys which law, Nana?
Distributive law.
Distributive law.
Yeah.
Okay. So the 3 laws here we can say for subtraction. It does not obey the commutative law, does not obey the associative law, but obeys distributive law. Okay. But how to find the magnitude and direction of subtraction of vectors? That we will go in the next class now. Okay. Can I wind up the class now?
Sir, once can we rewind the page?
Sure, ma'am. Can I go back to previous page? Yeah.
Sir, 1 minute, sir.
Sure, Nana. So is it over?
Okay, sir. Thank you, sir.
Sir, can you please rewind the page? I mean,
Which
turn the
page,
page.
Nana? This is actually third page.
Sir.
Next
Second,
page.
fourth page.
Yes, sir.
Okay.
Thank you, sir.
Okay, Nana.
Thank you,
Okay,
sir.
thank you. For you all. Okay.
Thank you, sir.
Thank you, sir. Have a nice day.
Thank you, sir. Have a nice day, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Okay.